This was a study that was funded by the Poultry Hub, but we have the AgriFutures logo in here because this is an AgriFutures event. And a little bit of background is that when we start to reduce the crude protein past what is normally done, we start to get limiting arginine, valine, and isoleucine in the diets. And so this experiment was to really zero in on the arginine and see what kind of a response we could get to diets that were deficient in low protein diets, deficient in arginine with plenty of valine and isoleucine added to the diet, because the arginine requirement is high in chickens, and this is because they lack a complete urea cycle. And then we also wanted to look at some other sources of arginine activity, including guanidino acetic acid, or GAA, and also L-citrulline, because these are both commercially available and can supply arginine activity. The citrulline has been examined many years ago as an arginine source, but pretty much it hasn't really been looked at in poultry recently. So why do we want to look at the low protein diets? And mainly to reduce moisture in the excreta. We want to have our excreta from broilers looking like the picture on the left, not like the one in the middle or the one on the right, because those can be negative for welfare of the broilers. So here's a chart showing the how arginine reacts on the in the chicken, and it's required amino acid in poultry. It gets into the GI tract, and it's important for protein synthesis as a essential amino acid for growth and feathering. It's also important in formation of nitric oxide from macrophages, and it can be nitric oxide is a vasodilator and very important in immune response. And as the nitric oxide is produced, then you get citrulline coming off, and citrulline can go back to cycle back into L-arginine. So we have an opportunity to put the citrulline in the feed here, and it has been noted that at least citrulline is used in humans as a vasodilator. It's sort of a poor man's Viagra, if you will, but it's kind of an interesting compound to look at. It's a non-protein amino acid and a metabolite. And then we have the other one, guanidino acetate, which is precursor of creatine, which is taken up by skeletal muscles and nerves, and that can also be formed from arginine. So if we have the need for more creatine and we supply guanidino acetate, we can spare arginine. Same thing with citrulline, we can spare arginine. So the aims of this project was to just determine the magnitude of response to arginine in low protein arginine deficient diets. And I don't know if I got in a little bit late, but sometimes if you're trying to produce a low protein diet, the wheat does not really help you much, because wheat can be highly variable in protein content. So it's something to consider. And then to compare the response to sources, those different sources of L-arginine. And the diets we formulated were either normal protein diets or low protein diets. And they were based on wheat, sorghum, soybean meal, canola meal, and had enough meat meal in there to satisfy the requirement for non-phytate phosphorus. So they had a pretty good chunk of meat meal in there. And meat meal, as you know, is fairly high in leucine, so we felt that we probably had enough leucine in the feed. And we had 768-day-old Ross 308 cockerels. As everybody knows, we have a hard time getting male broilers now. So these were males from the male line obtained from Goulburn from Aviagen. We had 16 birds per pen, 8 treatments, 6 replicates per treatment. And we had the reduced protein diets. They were 4% lower than the normal protein diets. So that's a pretty good chunk of being lower difference in protein content. But if you look at the numbers there, the starter diet, the normal protein diet was 24.9 versus 20.9 for the low protein diet. And the grower 23.7 versus 19.7, finisher 21.4 versus 17.4. So the normal protein diets were perhaps a tad higher than what one might consider normal. And then the arginine sources were added at 2 levels, 2.38 kilos per ton or 4.76 kilos per ton to satisfy the arginine requirement, which was the same as what was in the normal protein diet with no arginine added. And then according to the manufacturer of the GAA, they have a claim of 77% arginine activity. So that particular source was added a little bit higher. And I might add that commercially, this product is used in the feed, but it's not used at those high of dose rates, probably more like 1.5 kilograms or 2 kilos per ton. So these are fairly high doses of the GAA. I mentioned this already, the diets contain meat and bone meal to cover the available phosphorus, and also were based on, I think, 25% sorghum, and then the rest of the grain was wheat and soybean meal with some little bit of canola meal. And interesting to note, and this kind of goes along with what Peter was talking about with the soybean meal, the reduced protein diets in this experiment had 35% in the starter feed, 26% in the grower feed, and 2.5% of the soybean meal as compared to the normal protein diet. So as we reduce protein, we're removing the soybean meal. Here's the performance and I'm only going to give you the 0 to 35 day data there. A normal protein feed intake 3611, body weight 2607, feed conversion 1.38, 96% livability. The reduced protein diet with deficient in arginine, so the protein was reduced. We added valine and isoleucine, but not arginine. We get a very significant reduction in intake, weight gain, feed conversion, and livability. And then when we added back either the low or the high dose of arginine, we get a very big response to that arginine. And it's interesting to note that the high dose of arginine, which was equivalent to the normal protein diet, gave a relatively poorer response for feed intake, body weight gain, well, not body weight gain, but feed intake, at least feed intake compared to the lower one. And if you look at the GAA, basically those numbers are much worse than the arginine in terms of body weight gain for both of the levels, and the high level was worse than the low level. And then with citrulline, we got the best performance at both levels with a nice increase with the second level relative to the first level for both weight gain and feed conversion. So what this suggests is perhaps we had too large of a difference in the protein content between the normal and the reduced. Perhaps maybe we had some, and we looked at all the other amino acids, the histidine and everything else, and Of course, if you look at the aviagen requirements for digestible amino acids, they don't have any of the, they don't have anything listed there beyond arginine, isoleucine, and valine. In other words, no histidine or phenylalanine or any of those essential amino acids. But we were probably on the edge with those based on the Evonik amino-chick numbers. And then we looked at relative carcass yield and bone strength with these, and there was some evidence that the GAA is important in muscle formation and perhaps in bone breaking strength. We didn't really see it here. The breast meat was lower with the GAA than it was with in the low arginine diet. The best situation for breast meat was with the normal protein diet. Interestingly, the drum and thigh and drumstick wasn't really affected too much by the protein reduction. We actually got slightly higher higher thigh and drumstick with the low protein diet with adequate arginine added back, or adequate GAA or adequate cysteine. Abdominal fat greatly increased in the reduced protein arginine deficient diet, and then adding the arginine back in the three forms reduced. And then very interestingly, the bone breaking strength was highly significantly reduced in the low protein diet, and then increased as we added the arginine back. So the outcome, reduction of 4 percentage points of crude protein reduces body weight and breast meat yield. Birds responded greatly to arginine when added back to deficient diets, and that was in all those parameters listed there. There were large and significant responses to the first level and a little bit less to the second level of each arginine source. In the case of citrulline, it was much better. In the case of GAA, much worse. So that concludes the presentation, and I think that probably more needs to be done in the area and examining citrulline. So, yeah, thank you very much.